Hi, welcome to the Calculus 3 assignment practice series. So in this video, we're going to take a look at our assignment number 4 worksheets. And this worksheets is we're going to talk about the cross product here. Okay, so we're going to work with several problems on the worksheets number 4 and about the cross product. So now I'm going to go to my worksheets here, and here we go. Okay, so for these ones here, just as always, I'm going to work few problems probably we did not cover in the lecture series, or it's a little harder in the actual series, or something we need to be careful. Okay, so the first ones here, I'm going to work is the problem number 15 here, okay? So number 15, it tell you, I want to find the U cross V and determine the UV is directly into the page or out of the pages here. So these ones here, basically, so the purpose for this one is try to make sure you understand we call it is the right hand rules, right? So let me put here the right hand rules here. Okay, so when you use the right-hand rule, the first things you need to be careful about the vectors. So like here, this is U cross V's, right? So if you take a look, the U is from here to here. Like, so this is initial point, this is end point. So in order to do the right-hand rule, they have to start at the same here. So that means you need to move this U to here. Right, so that means this will be the similar use here, right? Because you start at the same here, and if this is 120, so what happened to these angles here? So this angle is 60, right? Okay, so now this is how do you put the, like use the right hand rule. So you put your fingertips here, all right, and then you kind of curve your fingertips to your thumbs, then to see where is your thumb go. So like for this ones here, you will find out your thumb will have to go what? Have to go into the page. So if you think this is the plans here, right? So then I know my U cross V's here will go into the pages here. So that means you're going to find a perpendicular. I cannot draw that on the paper here. That means you can find a perpendicular vector which is go inside the page, and which one is perpendicular to both U and V. Okay, so now also the problem asks you to find the U cross V here, right? So U cross V, so I'm just using the formulas here. We say it's U, V, and the sine theta here, right? So the U is 12 and the V is 16. So what is my sine theta here? Remember, right? So it's the U and V's intersections here. So has to be what? Has to be this angle. So this angle is what? It's 60 degrees, right? Okay, so that's why you got the sine 60 degrees. And so the answer here is 96 square roots of the 3 here. Okay, so be careful about this is what this problem, the purpose for this problem, they want to make sure you understand, when you use the right hand rule, what that means here. All right, so that means you both of the vector has to start at the same points here, right? Then you put your fingertips to the U because it's from U to V, so it's U. Then you kind of curve to the thumb, then to see where your thumb going to go. Okay, so the next one here I'm going to take a look is the number 19 here. So let's say find two unit vectors and orthogonal to the 3, 2, 1 and negative 1, 1, 0. So we know what is the cross product? Cross product, let's try to find the vector perpendicular to both vectors, right? So I know this vector, I can just do the cross product 3, 2, 1. Then I cross product -1 and 1 and 0. And in here, I'm not going to go over the math, like how do you do the cross product? I assume you know how to do that. So I'm just said, okay, after I do that, then this is what I got. I have -I minus j and plus 5k here. So basically, I have these vectors, -1, -1, and 5. And this vector is going to be perpendicular to both 3, 2, 1 and -1, 1, 0. Okay, so now from the first lecture, we know how to find the unit vectors, right? Okay, so unit vector is basically you find the length of these ones here. So the length here is -1, -1, 5, right? So this will be -1, -1, 5. So what is the length here? The length will be, right? So it's the 1. So this one's, oh, I'm sorry, this is, okay, so I got one mistake here. This is a K, not it's a 5K here, all right? So this is a K. So this is 1 here. Okay, so the length here will just be the square roots of the 1 square plus -1 square, -1 square plus 1 square. So it's 3, and the -1, -1, and this is 1. Sorry here. So this is 1 here. All right. So now why they say, hey, find the 2 unit vector? Because I know, like if you have like the cross product, right? You always produce 2, because of the cross product, they could be go up or go down, right? So you could go to the opposite direction. So one of the unit vector, you can do like this. So the next unit vector, so basically your 2 unit vector you can do is really is square roots of the 1/3 and it's -1, -1, 1. See here, because it's a positive and negatives, right? So one of them is just what we did here. So this is the first one. So what is the next one here? The next one will be the square roots of the 3. Then this is 1, 1, and the -1, right? So that's what is the 2 unit vectors. Because we know, because the one vector, like this is the vector, the perpendicular to both these vectors in the one direction, then I'm going to have -1 will go into the next directions, right? So that's why it's plus and minus. Okay, so that's it. All right, so now the next problem. So other problem, I think you can do okay. See here. So the next problem I'm going to work is number 31 here. Okay, so the number 31 here. So we said, okay, so the number 31, it tells you, okay, I'm going to find a non-zero vector orthogonal to the plane and go through the points P, Q, and R. So in the geometry, right? So in the geometry, we know 2 points defined a line, right? 2 points defined a line, unique lines, right? And also in the geometry, we know the 3 points defined what? Defined a planes here. Okay, so what is they try to ask you to do here? So they said, hey, I have a plan here, right? So this is like a PQR, they define the planes here. And now I want to find orthogonal vectors here. So that means I'm going to find a vectors here, which one is perpendicular to these planes here. And then also I'm going to find like this is a PQR. So this is a PQR, right? So because of PQR define the plane. I also want to find the area of this triangle defined by these 3 points. So how do I do that? So I'm going to, so the first thing's here, right? So I'm going to find the we're going to find these vectors here, right? So this is the orthogonal vector perpendicular to the plane. So now how I'm doing that. So we said, I know the cross product produce orthogonal vectors, right? So the first thing I say, okay, let's define the two vectors on the plane. So the PQ is the Q minus P, so it's a 4, 3, and a -2, correct? Then, so this is the PQs here. Then also I have a PR, right? So PR is the vector is 5, 5, 1s, right? So I know I can define this, so just like in here, right? So I can define a PQ, I have defined a PR. Then by the cross product concept, I know I'm going to, so if you do a PQ cross PR, what going to give me? So if, so I already did this. So this is 13, 14, and the -14 and the 5. So this is the vector. This is this green vectors, right? So these green vectors here is 13, -14, and the 5. So this is the vector going to be perpendicular to both these two vectors, PQ and PR. But we know from geometry, the 3 points unique define the plane. So that means these 3 points are on the same planes here. So if this vector perpendicular to those vector, of course, this vector is perpendicular to the what? To the planes here, right? So this is the part A. Then the part B, let's say, hey, find the area of this 3 points, right? So I'm going to find the area of these triangles here. So how do I find the triangle? Then you say, oh, triangle. So if you find the parallelogram here, what happened here? So the area will be what? Area will be half of the area of what? Parallelogram, right? So the area will be half of the area of the parallelogram. So what is the parallelogram again? The parallelogram is the length of this, right? So it's the length of the PQ cross PR, right? So it's the length of it. So this is the half. Then here, the length will be 13 square plus -14 square and plus 5 square, right? So I will have is the 2 of the, if you put into the calculator, it's 390 here. So that is how do I find the area of the triangles, right? So this is the area of the triangle of the PQR. Because I know from the geometry, the triangle is the half of the, right? So it's half of the, there is a half of the parallelograms, okay? All right, so now let's take a look. The next problem I want to do, the next problem I want to work on is the number 33 here. Okay, so in the number 33, we're going to introduce a key concept. It's a coplanar, okay? So I want to see, so this problem here said, hey, I have 3 vectors. I have U, V, and W. I want to see, because any 2 vectors is always, it can be on the planes, right? So it's a coplanar for any 2 vectors. But, so if I have the 3rd vectors, I want to see the coplanar. How do I do the coplanar, right? So we say, okay, how about, if the 3rd vectors, if the 3rd vector is also on the same planes here, so what happened? So will these 3 vectors will be able to suspend a parallel pipe? No, right? Because of all 3 of them on the plane, so they cannot span a parallel pipe. So that's why I say, okay, if I can prove the volume of the parallel pipe is equal to 0, then I can say, hey, you know, these three, they are the coplanar. That means they are laying on the same plane, and these three vectors, they cannot span a parallel pipe. So how do I get the volume of a parallel pipe? From our lecture, we said, oh, parallel pipe is the triple product, right? So, okay, so we'll say the U triple product is U dot V plus W, right? So then this one's here, you can say is just put it here. So it's 1, 5, -2, 3, -1, 0. And this is a 5, 9, -4. So if you put it into a triple product, and then you you use the method we talk about and find the determinant, then this one is the 0. That means what? So we know the volume of a parallel pipe is equal to 0. So what's that mean? So this three vectors are coplanar. Okay, so that's the problems I like to do. Okay, now let me see what is the next ones here. All right, so the next one I like to do is, okay, it's a problem 43. This one is a pretty good problem. So let's say if A dot B, this is kind of combined the dot product and cross product together. So let's say if A dot B is the square root of the 3, and A cross B is 1, 2, 2. So what I want to find the angle. You say, oh boy, don't, you know, like if they give you the length of A and B, then you can either use the cross product or dot product to find the angle. Unfortunately, it did not give you the length of the A, and this one we unknown, the length of the B is unknown. So how do I find the angles here? Okay, so now the reason why I say it's good because we use both concepts. So I know the A dot B, all right? So the A dot B, we have this is A, B, and the cosine theta, right? Then we also say that, hey, the A cross B, the length of the A cross B is A, B, and the what? Sine theta, right? Okay, so now if I kind of, okay, I kind of divide each other, all right? So what I have here, so I will have here, right? So look here. So the A and A cancel, B and B cancels here. So what is the cosine theta over sine theta? So what is the cosine theta over sine theta here? That it will be what is the cotangent, right? So cotangent theta is equal to the A dot B. Okay, so this is the A dot B and the A cross B. Am I right? Okay, so now let's take a look at what is the A cross B, the length of the A cross B. So it will be what? It will be 1 plus 4 plus 4. So it's 9 square roots. So it's 3, right? So it's 3 here. And the A cross B is here. And this is the 3. Then A dot B is the square root of the 3, right? So by your unit circle, so what is the theta will give you the cotangent equal to the square root of the 3 over 3? It's 60 degrees. All right, so that's why we know the angle between the A and the B is 60 degrees. All right, so the next thing I'm going to do is number 43 here, no, 45 here, right? So this one's here, this is the, you know, from our lecture in the cross product. And we proved, so in R2, I don't know you guys, you still remember or not, sort of, like in the lecture number 3, the dot product, we say in R2, right? So we have a line, the line is like ax plus by plus c is equal to 0. Then I have a point, right? So I have a point. This point is x1, y1. Then we set the distance from this point to this line. What is it? You guys still remember? It's a squared plus b squared, right? Then you plug just x1. So this is x1 plus by1 plus c, right? So we said this is the distance in R2. If you have a point, right? So if like in R2, you have a point to the line, that's the distance. And then now we are extend this. We said we have line in R3, all right? So we have a line in R3. That line goes through the point Q and R. Now I want to show the distance from the point P to the line L. Yes, this is the formula here. Okay, so first, we know how to define the line in R2 is ax plus by plus c. In R3, we don't even know how to define the line yet, right? So that will be our next lecture series. Lecture number 5, we're going to talk about it. So we don't even know what is a line's function looks like. So let's take a look here. So see how easy we can do this, right? So this is the the Q here, and this is the line we say in the R3s, right? So QR, so this line goes through QR, and then we can say this line is here. Let's say this is the vector A in the space, all right? And then I have a point P here, all right? So now let's see here. This is the vector, so QP, and I will say this one is the vector in the B, right? So remember, this is, right? So this is in the R3s here, right? Okay, so now I'm going to find the distance, right? So this distance from this point to this line, so it's a perpendicular distance, right? So that's what is the distance here. We say this is my B's here. And also these two, you're going to have an angle thetas here, right? Okay, now let's take a look at how do we do it. So in here, you see here, right? So the distance, right? So the distance we try to find, it really is the length of what? Okay, so let's say this is the point S, right? So it's the PS, right? So it's the length of the PS here, all right? And now the PS here, so this is the distance, right? So now I know this one here is by the right triangle. So it's the sine theta times the QPs, right? So this will be B, the length of the B of the what? Of the sine theta here, correct? And then from so what is the sine theta? By that very famous formula we did. Okay, so let's try to refresh the memory. So we said A cross B is equal to what? Is the AB sine theta, right? So what is the sine theta here? So the sine theta here, it will be what? Will be AB, and this is what? A cross B. Ta-da, cancel. How easy is that, right? So it's A cross B over A. So this is the formula for a point, right? Get into the line. What is the line? And this is not in the R2 anymore, right? So if in R3, like I said, we don't even know what is the line's formula in the R3, right? We have X, Y, Z. So how do we write the line formula? And you will say, hey, how about ax plus by plus cz plus d? Too bad, ax plus by plus cz, we say, is a plane, right? So it's not a line. So how do I write the line equation? That would be a very interesting topic. We're going to talk about it in our next lecture, number 5 here. So, okay, so that's how do we get the distance here, right? So then for the part B is here, let's say use the formula in the A to find the distance from the point. Okay, from the point 1, 1, 1 to the line goes through Q and the R's here. So we can say, okay, so A, we say, is the QR, right? Just like we did this graph here. So A is a QR and is equal to -1, -2, -1 here. And the B is what? B is the QPs, right? Okay, so B is a QP, so it will be 1, -5, and a -7, right? Then you can just go ahead and see what is the A cross B. So in here, the A cross B I have is 9, -8, and 7, okay? Then you'll be able to find the D. So I'm going to leave like you guys to get the detailed procedure in, and but I think the final answer for the distance will be the 97/3 here. So you can plug into the formula and see whether you can match my answer here. Okay, all right. So now the next one's here. So this is also, remember we just did the problems like the find the perpendicular, the orthogonal vector to a plane, right? So now in here, let's take a look at what is number 46. Let's say P is not on the plane, right? Then this plane was spanned by what? By the 3-point QRS. So now I want to find the distance from the P to the plane, and this is the formula here. So this is the formula here. So how do we get it? All right. So how do we get these formulas here? Okay, so let's take a look. So remember, right? So this is my plane here. So we know the 3 points can suspend what a plane, right? So this is we say it's a Q, R, S, right? 3 points can suspend a plane. And then we know the cross product will give you what? Will give you orthogonal vectors here, right? So we'll give you orthogonal vectors. So if here is my P, this is my piece here. So now think about this concept, right? So in here, so you can say here, right? So you will say, like A, you can say A is QR. So you say this one here, I give this is my A. So this is QR. And then B is here. This is QS. Right, so you can say I defined a vector is QR is A, and then the QS is what? It's B. So we did a similar problem in the previous like numbers here. So now, right now also this vectors here. Okay, so this is the vector. Let me see here. Okay, so if you hook this ones here, ding, ding, ding here, right? So if you let this vector, you say the QP, right, is equal to C here. So what is the distance? So think about it. If you have AB, so this vector is C, right? So if you have AB and C, what the AB and C will span? It will be what? So the vector A, B, and C, they will expand what? They will span a parallel pipe, right? It's a slant box. They will span a parallel pipe. Now we know the volume from the while ago, the lecture series, we said the volume of the parallel pipe. What is the volume of the parallel pipe? Will be A cross B dot product C. That's right. So what is okay, so this we from the, now we also know the anything the area, the volume will be area times the what? Times the height, right? The height, here the height is what? Here the height is our distance, so it's this here. Then also by the parallelogram, by the parallelogram series, I know what is my areas here. My area is just the length of the A cross B, right? So now in here you have these formulas here, right? So you have here the A cross B, right? So A cross B dot product C is equal to the A cross B times the distance. So what is the distance here? It will just be A cross B. Then here this is A cross B dot C here. So it's very easy to prove, right? So I think that after you have this formula, then everybody know how to do it. Just plug it into the B here, right? Right. So here the key things to remember in these worksheets here is you might want to write these formulas here, right? This is the distance from a point to a plane, right? And this is the distance from a point to a line in the R3, right? And also don't confuse, this is the formula, the point to a line in R2. So you want to kind of make sure you understand the differences here. And both the proofs are pretty straightforward, right? So those are the application. The geometry applications, it simplifies a lot, especially right now, like in the geometry, we never talk about R3, what is a line looks like, right? We don't even know how to write a linear, the line equation in R3. So how do I find the point, the distance here, okay? And then in here, also how do you find the angle between like the two vectors? Even I don't know the length of each vectors here. Then the other things here is a coplanar concept, right? So I guess that's it. And also like in here, how do you find a non-zero vector to a plane? We use cross product concept. Okay, so in here, why we have two unit vectors is because the cross product produce the one direction, the perpendicular vector. So you always can have the opposite direction still is perpendicular to it. All right. All right. So that's it. And that is the this assignment lecture number 4. It is pretty good assignment, and also show you that we both have the mechanical applications and also the geometry applications here, right? All right, that's it. And have a good day. And looking forward to talk about the next topic, like we say, how do I find a linear line in the R3? How do I write it? All right, what is the equation looks like in R3? That's it. Okay, so you have a nice day and talk to you later. All right, bye-bye.